Hi everyone and welcome to this video. In the video today I'm going to talk about the index laws and we're going to have a look at how we can use them to simplify expressions. Now hopefully you have a little bit of knowledge about these index laws already. I'm just going to run through them really quickly. So the first one is a to the m multiplied by a to the n is equal to a to the m plus n. What this means is that when we are multiplying we end up adding the powers. The second index law is a to the m divided by a to the n is equal to a to the m minus n. So here, it's just really the opposite situation, but if we are dividing two indices, then we subtract the powers. The third index law is a to the m all to the power of n is equal to a to the mn. So what happens there is we multiply the powers. The fourth index law, ab all to the power of m, is equal to a to the m multiplied by b to the m. So each thing inside the bracket gets raised to the power. The fifth index law is a to the power of 0 equals 1, where a is not equal to 0. This is because 0 to the power of 0 is undefined, but any other number it works for. The sixth index law, a to the power of negative m equals 1 over a to the power of m. So this is a really handy one because it enables us to change from a negative index to a positive index. And the seventh index law, the nth root of a to the m is equal to a to the m on n. So in this case, the type of root determines the denominator in the fraction when we change it to a power. The other part that I'd like to draw your attention to is this bit right here. So just a little bit of the language that I'm going to use. The a in this case refers to what's called the base, and the m is called either the power, the exponent, or the index, and you'll probably hear me use all three of those throughout this video. So let's have a look at some questions. Simplify the following. 2 to the power of 5 times 2 to the power of 3. Starting off pretty nicely. So in this case, we are multiplying these two things. The base in this case is 2, and so that base, it doesn't change, it just stays the same, as we can see up in the very first index law. A to the power of m times a to the power of n equals a to the m plus n. So the base has remained the same, and we just add the powers. So that becomes 2 to the power of 8, and we're done. Second question, 4x to the power of 7y times 6x squared y squared. In this case, the 4 and 6 are really just coefficients, they aren't a base number. So we do actually multiply the 4 and the 6. So that's going to give us 24. Then we've got x to the 7 and x squared. So in this case, the x is the base and the 7 is the exponent or the power. And likewise, the x is the base and the 2 is the power. So in that case, we simply add those powers. We get x to the power of 9. And we've also got the same situation with the y's. So we've got y to the power of 1, when there's nothing written there, it always indicates power of 1, and then multiply by y squared, so we're going to get y to the power of 3. And that's as simple as that one will go. Question C, 15a to the 6, b to the 4, c to the 8, divided by 5a cubed, b squared, c cubed. Right, so again, the coefficients are just that, they're coefficients, not bases in this case. So we're going to do 15 divided by 5, which is 3. We've got a to the 6 divided by a to the 3. So the a is a base. We just subtract the powers. So we're going to get a to the power of 3. Again, the b is a base. So we're going to have b to the 4, take away 2, which makes just b to the 2. And for the third term, we should have c to the power of 5. Question D looks a little bit trickier, but it's not too bad. So in this one here, well, first I'm going to multiply those coefficients in the numerator. So 1 times 4 is just 4. Then we're going to have a to the power of, and adding the powers in the numerator, we're going to get 3x minus 2. And that's divided by a to the power of 3x minus 2. Next thing, well, you could look at this in two different ways. You could look at it and say, oh, the a to the 3x take 2 is just going to cancel out. I'd like to do it using the index law for the power of 0 though, because when we have some kind of problem like this where we have something divided by something else, we subtract the powers. So first I'm going to do 4 divided by 1, which is 4. And then we're going to get a to the power of 0, because the 3x take 3x will be 0, and then negative 2 take negative 2 will also be 0. A to the power of 0 is 1, so 4 times 1 is just 4. Question E, 4 to the power of negative 3. So this is using the rule for the negative indices. So I'm going to change that into a positive index by moving it into the denominator. This is going to be 1 divided by 4 to the power of 3. Well, we could perhaps make that a little bit nicer by just evaluating 4 to the power of 3, which is 4 times 4 times 4, which is 64. 3/5 to the power of negative 2. So this is the situation where we have two things inside the bracket. Each of them needs to be raised to the power of negative 2. So I'm actually just going to change this to begin with. I'm going to change it to a positive index. So it's 1 divided by 3/5 to the power of positive 2. Squaring each of those things inside the brackets gives 9/25. And 1 divided by 9/25 should be 25 on 9. Just using stage change flip. At the present there I have 1 divided by 9 on 25, which is the same as 1 times 25 on 9 using stage change flip. Question G. Again, we have multiple things inside the brackets. I might just take this down to the next line. So everything that's in the brackets there must be raised to the power. So 4 to the power of 2 is going to be 16. A to the power of, we multiply these powers, so 5 times 2 is 10. B to the 14 divided by 2 cubed is 8. A to the power of 1 cubed, multiply the powers, we get a to the power of 3. B to the power of 4 cubed becomes b to the power of 12. And then just a matter of simplifying this. So 16 divided by 8 is just 2. Again, those are coefficients, so we can just divide them. A to the 10 divided by a to the 3 is a to the 7. And b to the 14 divided by b to the 12 is b to the 2. Question H, the last one. It's a little bit trickier. The problem here is that we can't really combine anything at the moment because they all have different bases. So we need to do a bit of work to make it so that they have the same base. So I'm going to make it so that these are all base 2 or base 3, because I recognize that 27 can be written as base 3, 4 can be written as a base 2, 9 can be written as base 3, 2 is base 2 already, and then the 18 could be a combination of the two. So the 9 I'm going to change into 3 squared. Two will just stay as it is. The 18, I'm going to write that as 2 times 3 squared. And then 4, I'm going to write that as 2 squared. And the 27 I'm going to write as 3 cubed. Alright, so that's looking much better already. And now it's just a matter of simplifying it. So next thing I'm going to do is expand these out. So 3 to the power of 2 to the power of x becomes just 3 to the power of 2x. Now, in this one here, we have two things inside the bracket, so each of them gets raised to the power. So we've got 2 to the power of x take 2 times 3 to the power of 2x take 4. Remembering that we multiply the powers. In the denominator, we are going to have 2 to the power of 4x plus 10. And then we're going to have 3 just to the power of x, because the 3 and being over 3 would just cancel out. Okay, next thing I'm going to do is I'm just going to group the terms in the numerator. So 3 to the, I'll do the 2 first. So 2 to the 3x take 1 multiplied by 2 to the x take 2. Add those powers, we're going to get 2 to the power of 4x take 3 Then we're going to have 3 to the power of. We've got 2x and we've got 2x take 4. So that makes 4x take 4. The denominator will just stay the same. And now, when we divide these, we can only deal with the ones that have the same base, but we will just subtract the powers. So we have 2 to the 4x minus 3 on 2 to the 4x plus 10. So 4x take 4x is nothing. Negative 3 take 10 is going to be negative 13. So we get 2 to the power of negative 13. Might write that a little bit better. And then that's multiplied by 3 to the power of. Now 4x take 4 divided by 3 to the x. So we're just going to subtract that, leaving us with 3x take 4. Well, that's about as simple as that one gets. I don't really want to go and evaluate 2 to the power of negative 13, but yeah, probably just leave it there. You might be expected to write with a positive index something like that, but yeah, that's about it for that question. So anyway, that's the introduction to the index laws. I'll leave that video there and see you all next time.